Welcome to qnawire.
Okay, so we're doing chapter 29, problem 17 here. So it says the magnetic field perpendicular to a single 18.2 centimeter diameter circular loop of copper wire decreases uniformly from an initial B of 0.75 Tesla to a final B field of 0. It says if the wire has, a diameter of 2.35 millimeters, how much charge moves past a point in the coil during this operation? Okay, well, the charge that passes a given point is the current times the elapsed time, because the current is charge per second. So if we charge per second times the number of seconds, delta t, that gives us the total amount of charge. We can now write the current in based on Ohm's law, based as the induced EMF divided by the resistance. So this is EMF delta T over the resistance. Now we can write the resistance by equation 25(3), such that we have EMF delta T cross-sectional area of the wire over rho L. Cool. So what else do we need here? Well, we need to figure out what the EMF is. Well, the EMF is the change in, with respect, or the change in magnetic flux over the change in time. So we have the delta T's are now going to cancel out, such that we have this left over. And we know that the area is constant, so the area of the loop here times the area of the wire times the change in magnetic field over rho L. Okay, so now we can plug in what we have for the areas here, and we see that we're left with, this is pi r loop squared, pi r wire squared, times delta B over rho L. If we simplify this all out, L equals 2 pi times r loop. So if we plug all that in, we get r loop pi r wire squared delta B over 2 rho. Cool. So now we just have to plug stuff in. So we have the charge here is equal to 9.1, or actually, let's make sure we do things in SI units. So it's 9.1 centimeters, so that's 0.091 meters times pi times 1.175 times 10 to the negative 3 meters, and then that's squared. And our delta B is the final minus the initial, but we just need the magnitude of it. So the final is 0, the initial 7.75, so 0.75 Tesla. And now 2 times our rho, which was 1.68 times 10 to the negative 8 meters. And now we can plug it in, and we get a Q of 8.81 coulombs. Cool.